section 11.4, our objective today is I can identify a series and use sigma notation. First of all, a series is when we add the terms of a sequence together. So for instance, a finite sequence which has the terms 2, 4, 6, and 8 becomes a series when we add those together. Okay? So this is a finite sequence and this is a finite series when we add the terms of the sequence together. If we have an infinite sequence, which in this case is the sequence 7, 9, 11, 13, etc. on to infinity, then the related infinite series is the sum of all those. So 7 plus 9 plus 11 plus 13 plus all the numbers after. Alright, and we can have, just like we have arithmetic sequences and arithmetic and geometric sequences, we can have arithmetic series, okay, and of course that is a series whose related sequence is arithmetic, and we can have a geometric series, which is a series whose related sequence is geometric. Now, it could get very tedious writing out this sum, because this is infinite. It could get very tedious to write that out because the next one is going to be 15, then 17, then 19, etc. And so to write that out, it's going to take a long time. So what we do is we abbreviate that using some special notation. That special notation is called sigma notation. So sigma is this Greek letter that looks like kind of like an E, and it's used to denote the sum of a sequence. Okay, so it's used to tell you that you're going to add up a sequence. So a series represented in sigma notation might look something like this, okay, where this is the summed or the rule, the general, or we're used to calling it the general term or the nth term, okay. The n, actually let me change this because this letter and this letter should match, so this should be an n right here. So 2n plus 1. The n is called the index, and the number next to the n is our starting term. In other words, it's saying we're going to add up the first term, and then the number at the top of the sigma tells you the last term. So this information is telling you you're going to add up the first 50 terms of the sequence. And this is the rule that gives you those terms. So to find those terms, I'd put a 1 in for n. So I would have 2 times 1 plus 1, or 3. And then I would put a 2 in for n. Then I'd put a 3 in for n. Oops, that should be a 1. Etc. until I got to 50. Okay? And so I would take those and add those up, all up. So 3 plus 5 plus 7 plus ... plus 101 says the same thing as all of this. This and this say exactly the same thing. Okay? So this says to add the first 50 terms of the sequence represented by, that should be 2n plus 1. Okay? So in other words, the sigma notation, this notation, is an abbreviated way to write a series. Okay? So, examples. All right, so if I want to, let's say, write the series in expanded form. So we're going to be given the series in sigma notation. So our first one is sigma of I equal 1 to 5 of 3i plus 1. Okay, so in expanded form, it's asking me to write out the addition of the first 5 terms. So the first term would be 3 times 1 plus 1. The second term would be 3 times 2 plus 1. The third term would be 3 times 3 plus 1. The fourth term would be 3 times 4 plus 1. And then the fifth term would be 3 times 5 plus 1. Okay, so notice that this number here matches this number, and this number matches the last one. Okay, so in expanded form, 3 times 1 is 3 plus 1 is 4, and that's 6 plus 1 is 7, that's 9 plus 1 is 10, 12 plus 1 is 13, and 15 plus 1 is 16. So the sum of I equal 1 to 5 of 3i plus 1 is exactly equal to 4 plus 7 plus 10 plus 13 plus 16. Okay, so that is the series of that sequence, right? Example 2. The sum of j equal 3 to 7 of j plus 7. Okay, so that is telling me to add up the third through the seventh term of the related sequence. So starting with 3, so I'm going to have 3 plus 7 is the first term, or the third term, but the first one to be added. Then I'm going to have 4 plus 7. Then I'm going to have 5 plus 7. Then I'm going to have 6 plus 7. Then I'm going to have 7 plus 7. Now I stop because this number matches this number. And where I started was this number and that number. So in expanded form, this would be 10 plus 11 plus 12 plus 13 plus 14. Okay? Now, we also want to be able to use sigma notation given the expanded form. So the directions would be use sigma notation to write the series. Okay? So, for instance, given the series, example 3, given the series 7 plus 14 plus 21 plus ... all the way up to whatever term is equal to 700. Okay? So first of all, what we have to do is find a rule. So what we want to do is the related sequence 7, 14, 21, is that arithmetic, geometric, or neither? Well, does it have a common difference? 14 minus 7 equals 7, and 21 minus 14 also equals 7. So this is arithmetic, which means then I can use the nth term formula for arithmetic sequences. So t sub n is equal to t1 plus n minus 1 times d. So I can use this formula to find the rule. Okay, so t1 is 7, n minus 1, and the common difference is also 7. So I get 7n is the rule. Okay? So in sigma notation, I have n equals 1 of 7n. But then I need to know, where am I stopping? What term is this? Well, in order to find that out, I take my t sub n equals 7n, and I put the 700 in for tn. So divide by 7, solve for n equals 100. So 700 is the 100th term. This is the first term, this is the second, this is the third, and we're adding up all the way up to the 100th. So 100 goes here. Okay? So this series is represented by this sigma notation. Right? Let's try another one. Let's try this one, number 4. Okay, so I have 1/3 plus 2/3 plus 1 plus 4/3 plus 5/3 plus 2. All right. So first of all, we want to see what we're trying to do is write this in sigma notation. And so what we want to do is see, first of all, is it arithmetic, geometric, or neither? Okay. Well, the related sequence is 1/3, 2/3. 1 is the same thing as 3/3, 4/3, 5/3, and 2, whoops, there should be a plus. 2 is the same thing as 6/3. So is it arithmetic? Is 2/3 minus 1/3 the same thing as 3/3 minus 2/3? Okay, well this equals 1/3. This equals 1/3. So it is arithmetic because you're adding 1/3 each time. And so we can use t sub n is equal to t1 plus n minus 1 times d. Okay, so we can fill in t1 as 1/3, d is 1/3, and so I get t sub n is equal to 1/3 plus n over 3 minus 1/3. So n over 3 is our rule. So we have the sum from n equal 1 of n over 3. And then what number goes up here? How many terms am I adding up? Well, here's 1, 2, 3, 4, 5, 6. So 2 is the 6th term. So the number that goes here is 6. So this is the summation notation for this series. Okay? And let's just do one more example. Example 5. I have -7/7 plus 7/4 minus 7/7 plus ... into infinity. Oops, I'm sorry, this should be a 1 here. Sorry. So it's -7 over 1 plus 7 over 4 minus 7 over 7 into infinity. All right. So we want to first see, is it arithmetic, geometric, or neither? Okay. So we have 7/4 minus a -7 over 1, which is going to be 7/4 plus 28 over 4, because I'm going to multiply top and bottom by 4 here, which is going to be 35/4. Then if I take -7/4 sevenths minus 7/4. Okay. Multiply top and bottom by 4, top and bottom by 7. So this is negative 28 over 28 minus 49 over 28. Well, this is going to be a negative number, so it's not the same as that. So it's not arithmetic. Now we want to check to see, is it geometric? Is 7 over 4 divided by negative 7 over 1 equal to 7 over 7 divided by 7 over 4? Well, if I flip this over and multiply, this is negative 1/4. And if I flip this over and multiply, this is 4/7. So it's not geometric. So now we have a problem. It's neither, right? So let me rewrite this so we can see it. So we have negative 7 over 1 plus 7 over 4 minus 7 over 7. Okay. Notice that the signs alternate. It's negative plus negative, and then the next one is going to be a plus. So when the signs alternate, there has to be a negative 1 to the n power. Okay? So now we have to figure out a pattern. Notice that the top number, whoops, let me use a different color here. The top number is always a 7. So it's going to be times 7 over something. Now we look at just the denominators. And we see, can we find a rule for the denominator? Okay. Well, notice that the common, it goes up by 3 each time. So there's a common difference. So the denominator is arithmetic. So we can use t sub n equals t1 plus n minus 1 times d to find the rule for the denominator. So it's 1 plus n minus 1, and the common difference is 3. Okay, so the rule that gives us each one of these denominators is 3n minus 2. Okay, so we have the sum from n equal 1, and the rule is negative 1 to the n times 7 over 3n minus 2. But then, how far are we adding up? Well, what do these 3 dots mean? I forgot to put them here. Those 3 dots mean to infinity. So that means I'm adding up to infinity. So this is sigma notation for this series.